Now question number 9. An open tank of the square base of side x and vertical side is to be constructed to contain a given quantity of water. Find the depth in terms of x if the expense of lining the inside of the tank which will be least. This is actually which will be least. So this is almost the similar question of question number 7. The difference is in question number 7 volume was given, but here volume is not given actually, but we have to contain a given quantity of water. Given quantity of water means that may be 4 or that may be 6 or any other value. 4, I would say that just create the similarity actually with question number 7. So again we have to make an open tank. In question number 7, that was the word used there was a box of a square base. Here we have to make a tank of square base of side x. So length will become x, width will also become x. We have to find the depth, or we have to find the height of the tank in terms of x if expense of lining inside of the tank. Lining is actually the material inside the tank actually, you can say, or we have to make actually the surface area again which will be least. So this one is actually the tank with side x, this one is actually the side, and this is depth of this tank represented by y, and we have to make this y in terms of x. Solution: let length of the tank is equal to x, width of the tank is equal to x as base is square, and height of the tank is equal to y, or you can say depth of the tank is y. Let Q be the quantity of water in the tank. Just the similarity with question number 7. The quantity of volume there was 4, but here we have a Q which is actually volume. So volume is given, which is Q, and by formula volume is actually length, width into height, so that will become x square y is equal to Q. We have x square y is equal to Q, and from here y will become Q over x square. Total surface area. Again, as we discussed at the start of this question, we have to make the surface area which must be least, or the minimum value of this surface area. And the surface area, as we discussed in question number 7, actually area of all sides, as the tank is again open with open top, so we have to construct this tank with a square base and all 4 sides. These are actually the area of all 4 sides, and this one is the area of base. So total surface area will become S is equal to x square plus 4xy. You can easily say that here the difference is only where volume is 4, and from there we get the value of y, which was 4 over x square, but here the volume is Q, so the value of y is actually Q over x square. So S is equal to the surface area is equal to x square plus 4Q over x. This one is not square because after cancellation. Now we will take derivative. So differentiate the surface area function with respect to x. So ds by dx is equal to 2x and the derivative of 1 over x will become minus 1 over x square. So this is actually 4q over x square. And the second derivative is actually ds 2s over dx square is equal to, and the derivative of 2x is 2, and derivative of 1 over x square minus 1 over x square is actually plus 4 2s are 8 q over x cube, because this can be written as 2x minus 4q x raised to the power minus 2, and after taking derivative that will become 2 plus 8q over x cube. Now for stationary points, put first derivative is equal to 0, that will become 2x minus 4q over x square is equal to 0, and from here we can calculate the value of x in terms of q. So x cube is equal to 4q over 2, and x cube is equal to 2q. So x is actually 2q raised to the power 1 by 3, the cube root actually. So this one is the value where our function, which is actually surface area, either may be maximum or minimum. And for that, put x is equal to 2q raised to the power 1 by 3 in second derivative, and the second derivative is actually in d2s by dx square, and that is 2 plus 8q over x cube, and here x is 2q raised to the power 1 by 3. This one actually d2s was 2 plus 8q over x cube. So just put the value of x here. 2 will remain same plus 8q will remain same. The value of x is 2q raised to the power 1 by 3. This cube will remain same. So after cancelling this 3, we have our second derivative 2 plus 8q. This one actually cancel out, 8q over 2q, and the second derivative will become 6, which is greater than 0. And if second derivative is greater than 0, then the function whose second derivative is this one will become minimum. So surface area is minimum at x is equal to 2q raised to the power 1 by 3. Now x cube can be written as 2q, just taking cube on both sides of at this value, so that will become x cube, and here 2q, and from this equation q is equal to x cube over 2, and put q is equal to x cube over 2 in equation number 1, which was y is equal to x cube over 2 over x square, as y was q over x square. So putting the value of q, that will become x cube over 2 divided by x square, and after simplification y actually was depth, so that will become after simplification x over 2, and the requirement is our requirement was we have to make depth in terms of x. X was the side of the this open tank, so the required depth will become x over 2. Question number 10. Find the dimensions of the rectangle of maximum area which fits inside the semicircle of radius 8 centimeter as shown in the figure. This one is the figure. So we have to find the dimensions of this rectangle with maximum area which can fit inside this semicircle with radius 8. So this one is actually the radius of this given circle. So let us start our solution. Let just change this diagram as let this one is the required rectangle with dimensions 2x and y. So this will become x, this will become x. The total length of this rectangle, of this required rectangle, is 2x, and this one is the width of the rectangle. So A, B, C, D is actually our required rectangle, and this one is suppose E. Let length of the rectangle is equal to 2x, width of the rectangle is equal to y centimeter from right angle triangle EBC. This one is actually E. So EBC is the right angle triangle. We have, by using Pythagoras theorem, hypotenuse square is equal to base square plus perpendicular square. So we have 8 square is equal to x square plus y square, and y square is equal to 64 minus x square, and y will become square root 64 minus x square. Now area of this rectangle, as our required condition is maximum area. So we must have to make a function which giving the area of this rectangle and make that area function maximum. So now area is equal to length into width, as the length of the rectangle is 2x and width of the rectangle is y. So our area will become 2xy, and putting the value of this y, which will become 2x into square root 64 minus x square. Now differentiate this equation area function with respect to x. We have dA by dx. Just using our product theorem, 2 as the constant thing will remain outside, and the derivative of this function, x will remain same, and we have to make the derivative of this second function, which is 1 by 2 64 minus x square, 1 by 2 minus 1, which is minus 1 by 2, and then derivative of this inner function, which is represented by minus 2x, as the derivative of 64 is equal to 0 and derivative of minus x square is minus 2x plus. Now 64 minus x square will remain same, and the derivative of x is 1. So finally our first derivative is equal to minus x square. This 2 will be cancelled out. We have minus x square divided by 64 minus x square plus this 64 minus x square will remain same. This one is the actually the repetition of first derivative. And now by simplifying, just by taking LCM, 64 minus x square square root is an LCM. We have minus x square plus 1 into this, and this will multiply by 64 minus x square. Square root will be cancelled out, 64 minus x square, and now dA by dx will become 64 minus 2x square divided by 64 minus x square. Now for stationary points, put first derivative is equal to 0. Two cannot be equal to 0, so this factor must be equal to 0, and as we know that if the fraction result give a result to 0, then numerator must be equal to 0. So 64 minus 2x square is equal to 0, and from here 64 is equal to 2x square, and x square is equal to 64 over 2. So x square is equal to 32, and by simplifying, x will become 4 into square root 2. Now we check, or by use our first derivative test. So before x is equal to 4 square root 2, our first derivative is greater than 0. From here, if we check the value before 4 square root 2, before 4 square root 2, or you can say 3 square root 2 before this value, or if we take x square is equal to 32, and before x square is equal to 32 we can take let 30. So if we put x square is equal to 30, then 32, the square of 30 and then multiplying by 2 must be greater than 64 and will give a negative value. So we have 4 square root 2 is equal to dA by dx, which is greater than 0. Sorry. By putting x square is equal to 32, so before x square is equal to 32, and let we say x square is equal to 30, and 30 into 2 will become 60, and 64 minus 60 will result 4, which is positive value. So here we have dA by dx is greater than 0. And after x is equal to 4 square root 2 in the expression 64 minus x square, and if we take x square after x is equal to 4 square root 2, let that is 5 square root 2, or x square is equal to 34 or 35, then by simplifying in this expression 64 minus 2 x square, and the value which is greater than 32, x square greater than 32 will become like minus 2 is that 35. So 64 minus 70, which is less than value. So that's why after x is equal to 4 square root 2 will return dA by dx is less than 0. And as we know that if the first derivative changing its sign from positive to negative, then the function, which is in this case area, is maximum at x is equal to 4 square root 2. And otherwise, if first derivative changes its sign less than 0 to greater than 0 or negative to positive, then function is minimum. But in this case, first derivative changing its sign from positive to negative before and after, so the area is maximum at our stationary point, which is 4 square root 2. So put x is equal to 4 square root 2 in equation 1, we will get the value of y by simplifying, which is again 4 square root 2. So we can say length of the rectangle 4 square root 2 and the width of the rectangle is also 4 square root 2.